Here we go, a typical question. The experiment was repeated 3 times, but with one change in condition in each experiment. Good. 2, 3, 4. Number 1. Instead of using 0.5 mole per dm cube of the acid, they use 1.0 mole per dm cube of the acid with the same volume. Sketched on the same axis, so based on the graph you expect for these 3 experiments, label each graph. So we're going to superimpose, always come out for 3 marks, damn good. Follow me closely, it's not anyhow and there are some rules. So here we go, Okay, ladies and gentlemen, this is experiment number 1. What do we use for experiment 1? Slow and steady. If I'm too fast, let me know, but I'm going very slow, I suppose. We use this concentration, make sense? 0.5 mole per dm cube of HCl. Now, how much did they use? They use 1.0 mole per dm cube, twice of it. Correct? In experiment number 2. Remember, this is a rate graph question, and I've shown you 5 out of 10 questions you'll be tested on rate graph. Yes? How many sections do we have to deal with? The answer is 2. Correct? It's my notes. Correct? The last section. My graph. When you describe a curve, there are 3 sections. But when you play with the graph, the curve, right? 2 sides only. 2 sections. Which 2 sections, my friend? The start and the horizontal line. Remember? When they change the experiment. That's all we are doing. All right? Let's do it. Okay, ladies and gentlemen, take a look at the concentration. In experiment 2, you use a higher concentration acid. So the initial rate of reaction. Remember, in chemistry, we only care about initial, time 0. The initial rate going to be steeper or gentler? The gradient, steeper, because the rate is faster. Okay? Don't draw in first. Because later the curve very ugly. So I expect it to be something like that. Everyone okay? A bit squeezy there, but you draw it like that, people will understand what you're doing. It must be steeper. The tangent to the curve must be steeper. So I need the second point. What point? The horizontal line. Do you think the horizontal line is here, higher or lower? Okay? We mentioned this before, right? How do we play? We need to calculate the mole. But to calculate the mole, I need to have the volume. Make sense? Ladies and gentlemen, can we fake it out or not? A volume. Let the volume, because the question says same volume. So let you see. Can I assume it's 1 dm cube? If not, whatever value there. Can? So here, same volume. So here is also 1 dm cube. Make sense? So you can calculate, right? So you can calculate what? You can calculate the mole, right? Concentration multiplied by volume, therefore 1 mole. Just to show you. Same thing, this is also therefore 0.5 mole. But very important is what? Is the HCl is the what reactant? It must be limiting. And in this case, it is the limiting. Question says so. Because the marble is in X. And when the mole of limiting reactant increases, the mole also increases. Mole of what? Or the volume of the gas increases. You double the mole of the limiting reactant, so your product will also, I know it's in the 40 cm cube line. Make sense, everyone? For a start. Okay, so my job right now, as I mentioned, is to do what? Is to join them. But it's not anyhow join one for some of them, okay? So let me clarify certain things before you join, right? Again, I say don't draw in the graph. You can write something. Okay, the question again is, remember a graph, essentially, Clarence, nothing wrong to say that. It has 3 sections, remember? Very steep, gentler, and stop. Okay, technically. But more important is, I hope everyone agree, the start of number 3, right, section, which is here, is called end of reaction. Right? So in experiment 1, we all know we end here, 2 point something minutes. The question next is, where should we end, and therefore also means where should we connect it? Make sense? Do we connect here, same line, or here? or here. Agree? It's just a sketch, I understand. Yeah? So some students say it must be here, there, or whatever, right? I want to share with you, ladies and gentlemen, it is actually quite okay, and therefore your marker should not mark you based on where you end it. But I always try to keep it quite close to the black color. Why can't? I share with you. Because when you have more reactants in this case, you have 1 mole rather than 0.5, you got more. Make sense? It will, therefore, by right, the rate is faster. Make sense? So we expect to end earlier. Correct, huh? But because you got more of the mole, you need more time to get all of them out. Make sense? So it might be later. Are you with me? So I repeat myself. When you have the 2 lines not on the same level, your marker should not mark you where it should end. Are you with me? If they mark you, it means simply they don't know chemistry. I think this teacher or whoever have never been to a lab and worked before. They only know academic theory. They never been to a lab and worked before because it doesn't make sense. No common sense. Make sense, everyone? So again, it will not mark you on that point. But just to play safe, I will always do this. All right? I will try to keep it to here. Plus, minus, not too far away from it, just to play safe. All right? So you can say it takes a bit faster, a bit longer, doesn't matter. All right? Again, there's the one. Sorry, my Wacom very smooth. I can't really draw properly. Somewhere around that, doesn't matter. Once again, we will not mark you. So I'll put a question mark. You're not supposed to mark you based on it, but don't go too far away from that black color line. Okay? Because it doesn't make sense. To know where it really ends, you have to conduct the experiment, collect the data, have the table of data, and you plot it out, and you will see. If not, ladies and gentlemen, this is the graph, and we get 0 for it. Why? Because we forgot to label. Very important. And I always see students don't do that. You can give all kinds of excuses. It's called never focus, lack of focus. Study so hard and you lost the mark. What a waste. All right, then we go to the second one, if you're okay with this. Again, the rest session is recorded. Number 2, all right, is you use a lower temperature. So lower temperature, this is easier. Lower temperature means what? Means the rate become slower. So I will have a gentler gradient. Make sense? And this is important. Always 2 points. First point, second point. The horizontal line, same or different? Same, because you decrease temperature, you won't get more things on. It's just slower. So when it's on the same line, it's now very important to show where it ends. It should end later because it takes a longer time for the same amount of product to come out. Experiment 2 or experiment 3, I think. Third, what is it? Smaller pieces of marble, which is calcium carbonate, but same mass, which is a good experiment. All right, but with same mass. All right, so what we know over here, if you use smaller pieces of calcium carbonate, it means what? It means surface area increases. So I expect the rate to increase. So my gradient to be steeper than the original experiment 1, and the reaction going to end early here. And again, because you use the same mass of the solid. Anyway, the solid is an excess reactant. It will not affect at all. So this is experiment 3. Experiment 4, sorry. IV. Can we change 2 conditions each time instead of 1 condition? Explain. Primary 6 science, this is a standard question, and we give them the answer. Answer is no. All right, in all science experiment. And I will just regurgitate this, something along that line. For an experiment to be conducted fairly, the factors or the condition or the variables, they all mean the same thing to me. And only we change once each time. With the rest, let me write it, remaining unchanged or constant. And therefore, this is a good experiment. If you would like to catch my latest videos, click on subscribe button right now. And click on the bell if you want to receive instant notifications once I've uploaded my latest video. If you'd like to join my live chemistry classes and revision workshops, go on to winnerseducation.com and find out how you can score distinction for chemistry on a consistent basis, either in our center or online via Zoom. If you want to check out my online school, go on to passwithdistinction.teachable.com. You'll be able to learn chemistry concepts at your own pace and anywhere in the world, topic by topic. This is Sean Chua from Winners Education, to your distinction in chemistry.